Hi guys, welcome back to the channel. Today we're going to be taking a look at smart receivers, what they are, how we use them, and setting them up with an FPP based controller. So in this video we're going to be looking at smart receivers and how we set them up with FPP. We're going to talk about smart receivers in general, what's the difference between a regular or standard receiver and a smart one. We'll look at some of the pros and cons, and then we'll look at configuring them in FPP. Now I need to start this video with a big thank you to the guys over at Builder Light Show. They have very kindly supplied the SRX receivers that we're going to demonstrate in today's video. They are, of course, the UK's and Europe's #1 provider of pixels. They are licensed distributors for Falcon, so all your Falcon products can be got from there. And they're cutting GE props here in the UK for the UK and European markets. So thank you to Jim and Nick for your support as always, and look forward to working with you on some new projects very soon. So what is a smart receiver and how does it differ from the standard receivers that we looked at in our last video? Well, the simple way to tell a smart receiver from a non-smart one is by the number of Cat5 ports. So a smart receiver will have 2 of them, whereas your standard receiver just has the 1. Now, why would we want more than one Cat5 port? Well, the answer is quite straightforward, because we can daisy chain them. So we can take 2 of them and simply loop a piece of Cat5 between the 2, giving us additional outputs at a remote distance. So I have here a couple of the original Falcon version 3, the original smart receivers. They're easily identifiable because they're the white ones. This one is actually a very slightly later release than this one. They're the same version, but this one was made later, so it's got silver ports rather than the black ones, but the functionality is identical. Now, the whole idea of the smart receiver port is that we can further utilize the long-range outputs by sharing the load or sharing the number of pixels on the port between a number of outputs. Now, what that means on an FPP-based controller is that your port outputs will be split up into sub-ports effectively. So port number 1, for instance, that we're outputting to a smart receiver, we can now split to port number 1A and port number 1B. And in the case of the white version 1 boards, we can have up to 3 in a row. So we could go up for A, B and C. Now, the thing to bear in mind is that our overall pixel counts per port on the controller don't change. So on an FPP based controller at 40 frames per second, we have a maximum of 800 pixels per port. Now, just because we've got 2 outputs doesn't change the number of pixels outputs available on the controller. So we still have 800 on port 1 on the controller, but that's being split now, and we can have up to 400 on each of these 2 for the total of the 800. If we were looking at 3, then we'd be looking at 266, I think it works out to, per port, because we've got 800 divided by 3. So bear that in mind when you're thinking about how to put them out. Now, just as we did on the last video with setting up a standard receiver, let's run through setting up the version 1, the white receivers, with our FPP. And then in a few moments we'll move on to setting up the V2s, and I'll talk about the new SRX boards in a bit more detail. So just the same as we did with the standard receiver, we need to get these things powered up. But before we do, we need to change some jumper settings on these to tell them their position in the chain. So we can have, as I said, up to 3 of these version 1 boards in a chain. And we need to tell them their position so they know which lot of pixel data is relevant for them. And then additionally on these Falcon boards, we need to set some jumpers to tell it that it's the last receiver in the chain. And we'll show you the modes that we need to set. So this one is going to be smart receiver number 1. So I need to be up on that one. Yeah, up on the right, down on the left. And then my terminators all need to be off. So there we go. I've got my mode is set to smart A and my terminators are turned off. So that's going to be our first one in the chain. And then this one I'm going to set as the second one in the chain. So I need to set my mode to, there we go, mode to position B. And I need my terminators on. So that's on. I've got 4 terminators for the 4 ports. Got it. 1, 2, 3, 4. Right, so we're on position B here, and the terminators are on. So that's going to be there. Right, so I need to get power to them first. So once again, here's my trusty Meanwell. And I'm going to do ground and power. There we go. There we are, that's those 2. And now I need another power cable for my second one. So I've got another couple set up here. There we go. So we've got both hooked up to the power supply now. I've used 12 AWG cable because I know that I'm not going to be drawing anywhere near enough power to worry these cables, so I'd rather be safe than sorry. You need to do the calculations to work out your power requirements and therefore your cable sizing. Right, next thing is we need to connect up the data cable. So I'm going to connect in my data cable running from my first receiver to the controller. And then I have another short one here, ready to jump across. Oh, there we go. From one receiver to the next. Then, of course, I need to connect up my pixels. Now, these Phoenix connectors are 4-way Phoenix connectors, but that doesn't mean you can use WS280, the pixels with data and clock on them. These smart receivers only support the 3-wire pixels, like the WS281X type pixels. Here's some pixels I prepared earlier, so let's get these plugged in. So I've got one lot into port 1 there, and one lot into port 1 there. There we go. So we've got our pixels connected, we've got power, we've got data. We just need to crack on with config. So let me give the smart receiver some power. There we go. Right, they've got power, so they're good, they're ready. Let's go into FPP and start the config. So I'm in the channel outputs tab where we left it from the last video, and we need to change the differential receiver type now from standard, which was the single type, across to smart version 1. There we go. And then we need to tell it how many smart receivers are in the chain. So as I said, with Smart version 1, which are the white Falcon boards, we can do up to 3 smart receivers. I'm only going to be doing 2 for this demo, so we're going to tell it that we've got 2. And it then tells us that we can configure port 1A through port 4A and port 1B through port 4B. So the A ports are all going to be on our smart receiver here, and our B ports are all on this one. So there we go, this one's A, this one's B. Right, so let's configure our strings. Now I've configured string 1, that's copied across from earlier, so that's set up for starting at channel 1 with 10 pixels. And I'm just going to move out, there we go, move out string 2 because that's no longer what we're playing with. There we go. And I can put string 2B, oh sorry, string 1B, string 1B. I'm going to give start at channel 31, so it follows our first one, and give it 10 pixels. Now, of course, you'll probably be doing this config type stuff in X-Lights, so you need to configure X-Lights appropriately for the different receivers that you've got set up. I'm just doing it in here for demo purposes, but yeah, you'll set it up in X-Lights, push the config via the UDP out, and away you go. Right, so we're set up there for string 1 A with 10 pixels and string 1B with 10 pixels. So I'll save that. And as soon as FPPD restarts, let's do that. There we go, we had a little flicker as they woke up. Okay, so they're now configured. And if I go to test pattern, we can see that the pixels are immediately doing their thing. Now, because this is the very first pixel on port number 1, it's lit up white. The first pixel on port number 2, the first 2 pixels on port 2 would be white because FPP tells you the string number when it's got power. These are additional pixels on port number 1 because they're receiver B, so we don't see the channel numbers illuminated there. Right, they're all doing their thing, nice and well. How do we prove that this is now configured as string 2 because it's not telling us what pixel number it is? Well, the simple way is we can go into the traditional testing on FPP. So we need to test pixels, we need to test channels 31 through 60 to prove that these are configured right. I'm going to go for status control, display testing. I'm going to change my channels for testing to 31 through 60. There we go. And then we can do a test. And there we go. We can see that our pixels are doing the RGB testing. And yep, that's all looking good. So we know now that channels 31 through 60 are coming out of the second smart receiver. So all good, all is working nicely. So that has demonstrated how to set up the version 1 smart receivers, which were for the version 3 type Falcon boards, the F16 V3, the F48 V3. Now recently, Falcon Controller announced that they are discontinuing production of these white boards for the Falcon F16, F48 V3s, and they're also discontinuing the blue boards that were designed for the Falcon F48 and F16 V4s. Both of those have gone now, and they've been replaced by a new range of long-range receivers, the SRX series. Now these consist of a 4-port receiver, just like we had before, just with a redesign. And this is compatible with both the F16 and F48 V3s and the F16 F48 V4s, and with the FPP type controllers as well. But what's also interesting with these is that we've got the 4-port version, and where we would normally have daisy chained 2 of these together to give us 8 ports, instead they've combined effectively 2 receivers into one to give us an 8-port variant. So we're still using the same 4-wire or 4-pair differential feed, but instead we've got port, if you like, 1A and 1B on the same board. So we're getting 8 ports out. And if you remember on the white ones, I said we could have up to 3 in a row. So you could daisy chain one of these and one of these to give you your 3 ports on a V1. But with the F16 and F48 V4s, the old blue boards, we could daisy chain up to 6 using the V2, the version 2 of the Smart protocol. So you could have up to 3 of these in a line. Now bear in mind that our individual port counts still matter. So where we have 800 pixels at 40 frames per second on a single port, we're now sharing this across 2. So we could have 400 on here and 400 on here. And if we had 2 of these daisy chained together, we could have 200, 200, 200 and 200. Now talking of daisy chain 2 of these together, we don't need to do that because we have the new SRX4 as well. And that's exactly what that is. It's effectively 4 smart receivers on one board. So we have port 1A, port 1B, port 1C and port 1D all on one board. And as I said a few moments ago, you can have up to 6 receivers. So you could, if you wanted to, chain one of those and one of those off a single Cat5, giving you up to 20 ports. If I've done my sums right, no I haven't, 24 ports even. 24 ports from a single cable. But bear in mind that your 800 would then have to be divided by 6. And if my maths are right, that's 133 pixels per port. So you might find that that's just too many, it's not viable. But 200 per port on one of these is a good number. Now if you're using an F16 or F48, then you don't get 800 per port. I think the maximum on an F48 V4 is 704 per port before you break it down. So 704 would drop down to what, 352, 176 per port on one of these, if I've got my maths right, and it might not quite be right because that's, yeah, me. Right, so let's have a look then at configuring this SRX4 on our FPP based controller. Now the first thing we're going to note is that typical with a big Falcon 16 port board, we've got 2 30 amp power inputs, which is great. We've got lots of amps coming in, and we just have the one, we're not going to daisy chain this one, so I'm just going to use the one port to go back to my WB48. Instead of the dip switch for the position in the chain, on these boards we've got a little rotary dial. Now that says for normal receiver mode, as in a standard receiver, that should be set at 0. I'm not sure why you'd use that on here because it would only give you 4 ports, so that's a bit daft. We've got settings 1 to 3 or A to C for Falcon F16 V3, F48 V3 and version 1 protocol of FPP. So version 1 protocol we can use, but obviously we could only use the first 12 ports because it can only do a maximum of 3 receivers. Or for version 4, we can do for A to F for pi, and BBB version 2 is jumpers 6 through 9. We're not going to do that. And then auto detect is A to F. So we're going to go to position A on this one for auto detect, and we'll see what that does for us. So let's just set that now to A. There we go. Let's put that onto A. And let's power up give it some power. So volts on the inside, ground on the outside. There we go. Boom, boom. There we go. And then, so as typical with a Falcon expansion, just watch out if you're plugging in your power, because the ground and positive are reversed on the 2 different connectors. So the ground is on the outside and positive is on the inside. So that's hooked up. Now we just need our short Ethernet cable again to bring the data in. There we go, that's plugged in. Let's turn the power on to the smart receiver. There we go, we can see that we've got all of our fuses, our output checks are illuminated, so they're good. Now I'm just going to plug in some pixels. So I'm going to go for 1. Oh, give it a wiggle. 2, 3, and 4. So I'm going for ports 1, A, B, C, and D. I dropped that. So let's plug in the pixels. We're going to go for 1, port 1. 2, 3, and 4. So that's port 1, A, B, C, and D. We've got our data. We're powered up. All that's left to do is to configure our controller. So let's go for input output setup, channel outputs. Now I'm going to change the configuration that we had for the smart version 1 across to smart version 2. And we can have up to 6, of course, but this is effectively the 4 smart receivers in one board. So we're going to set that to 4. My position indicator is set to A. My terminations are on, so that's all good. So now we can configure string 1A, which will be this first one, has got 10 pixels. String 1B is going to be this second one, and that's again set up for 10. So now we can add string 1C. Again, I'm going to put, that's going to start at 61 for 10, ending at 90, and string 1D is going to be from 91 for 10. There we go, ending at 120. Yep, so we've got 10 pixels per port for this demo. they're all configured on string 1, A, B, C, D. Yeah, we're good. So let's save that. Now again, that would normally be done in X Lights. You need to tell it the type of controller, the type of expansion, so that we're using version 2 smart receivers, and that we've got 4 of them in a chain. So that's done. We'll restart FPPD. It says it's restarted. We'll just wait for that to go. There we are. That's now cleared, so we can now go into our test pattern. Oh, and it took it a moment. It made me think that I'd done something wrong, but it's now jumped into life. We can see that we're on pixel output 1 because the very first pixel is illuminated white as for the FPP testing, and the rest are doing their RGB sequencing. So we're good. We've got all 40 pixels up and running here doing their thing. So that's awesome. Now, as I did with the whiteboard, I'm going to go and check that each output individually is doing what we expect it to be doing. So I'm going to stop this, and I'm going to go for status control and display testing. I'm going to do a cycle this time of RGB, and I'm going to test my individual outputs. So output 1 is going to be channels 1 through 30. There we go. So we've got test 1 through 30 and test. And there we go. So our first string is now doing its RGB test. So that's good. And nothing else is active. So that's good. The first 30 channels then are coming out of there as I expected. I'm going to test 31 then through 60, which will be my 10 pixels hanging off port B. So that'll be this lot. And there we go. We have our 10 pixels here doing exactly what we expected. We can then test channels C, which are going to be channels 61 through 90. Yep, that's the third string. They're in a bit of a tangle here. Yep, the third string are all doing what we expected. And then last but not least, channels 91 through 120. And there they are, coming off of the fourth, the D port on this expansion. So there we are. We've completed our testing using the new SRX4 here. Now, I think you'll agree that this is quite a remarkable change for the community from the original sort of 4-port designs, hence the WB48. We've got 12 long-range expansions. Each one has 4 ports, hence the 48. And the same with the Falcon F48. But by expanding this now to 16 ports on an expansion, that takes us up to a maximum of 192 if you just use the 12 of these 16 port expansions. So quite a remarkable jump. Yes, you've got to bear in mind that you have effectively still only got your 48 ports and your pixel counts of 800 per port across the 48. Or indeed, if you're using a Falcon F48, then you're looking at 704 with the V4s spread across the 4 ports. So for your FPP-based controller, you're limited to 200 pixels per port across the whole lot. Or on your F48, you're looking at about 175. But even so, I don't personally run more than 200, 250 pixels per port because I don't want to play with power injection and that sort of nonsense. So these are going to be beautiful for me. I can limit at 200 and just max out my controller. So really, really good upgrade, and yeah, it's going to be quite a game changer for the community. So as always, I think that brings us to a wrap. We've got the SRX4 with the 16 ports. We have the smaller SRX2 with the 8 ports, A and B. And then the SRX1 with the 4 ports. All three are compatible with both the version 1 and version 2 of Smart Protocol. So they both work with your FPP based controllers, and they all work with both your F16 and F48 V3 and V4 boards. As always, I hope you found that useful. Please do stay safe, like and share, and don't forget to subscribe. Look forward to seeing you on the next one. Take care. Bye for now.